Global fuel consumption is increasing at an unprecedented rate due to urbanization and industrialization, resulting in ever-increasing CO2 levels, surpassing 400 parts per million in contrast to 290 parts per million during pre-industrial times, which has long been considered by scientists as a danger zone of climate change. Soaring oil prices coupled with threats of climate change puts pressure on the need for renewable and sustainable energy sources. Biofuels produced from microalgae have been increasingly gaining widespread attention as a sustainable energy source. The lipid and hydrocarbon content of microalgae can be extracted and converted into biofuels that can be used in the transport sector, which is currently contributing to 1/5 of the world's carbon dioxide emissions. Unlike conventional oil crops like palm oil and soybean, microalgae do not compete with the land in the food industry and can be cultivated on marginal land with insignificant conservation value or on ocean surfaces on floating screens. Microalgae usually has a harvesting cycle of less than 10 days, allowing for faster cultivation than conventional crops and have higher oil productivity. They also degrade quicker, and its leftover biomass can be used as animal feed. They are also able to utilize water contaminated with fertilizers as its principal source of water, which allows for fewer resources to sustain the microalgae. Despite their enormous potential, many studies suggest that a complete substitution of petroleum-derived fuels by algal biofuels is unfeasible from an economical perspective as it cannot meet current needs. Although algal biofuel research began several years ago, lack of funding and relatively low petroleum costs put studies on hold. Despite these drawbacks, marginal replacement by biofuels can still successfully delay the exhaustion of petroleum resources and curb climate change. Dedicated efforts on the research and development of algal biofuel cultivation and harvesting techniques can further curtail their CO2 emissions. With the advancement of technology and possible government incentives, there is still hope that microalgae will become economically feasible in the long run.